Yes, so today we have presentations coming from people from both academia and industry. The title of our webinar today is Connecting Freight and Metro, Data-Driven Innovation for Urban Logistics. My name is Andres Gabrielides. I'm part of the iLab team here in IMEC and in the University of Antwerp. And we are going to present work outcomes of the Spanish use case pilot and more specifically come from scenario 2. So in advance, I want to thank all of the Spanish use case for the contributions, and without them, of course, this webinar would not have been available. Would not have been able to complete. I'm leaving a few seconds, our social media, so LinkedIn and YouTube primarily. As I said before, in YouTube, you will find many videos, including different tutorials that we have produced, pilot information, the webinars that the project has produced, for Freight project. So please take a minute. We will make available all the slides to all the participants, both people who are participating in groups online, people who are here, of course, the online participants in the call. Okay, so first, let me start a little bit with the agenda of today. So we will have a brief introduction to the For Freight project, then discussing the existing problems and benefits that the For Freight solutions are there to tackle and provide to the public. Then a small introduction to the Spanish use case and the solvers that are associated with the use case before introducing the specific solvers of scenario 2. We will see later what scenario 2 is and the solving process. Then a short presentation of the For Freight platform in slides, and then a small go through of the platform in online, so live demonstration. But as I mentioned, you can find videos that are way more comprehensive, and you can follow through our YouTube channel. And finally, we will discuss a little bit of the perspective of the future deployment of Freight solutions. And then coming from 3 colleagues, we will have presentations that represent the view of AI in transport and logistics coming from academia. So Hansi Dennis and Sigrid Messelis will be the academic, let's say, representatives. And Maria Ramirez Gutierrez from DHL will give us the industry perspective for how, coming also from the project. So DHL is a partner in the project, and we want to, we will hear their perspective on the use of artificial intelligence in transport logistics from the perspective of industry. Then, okay, the goals of the webinar is to demonstrate how the use of AI in the transport and logistics sector will help move forward the next generation of logistics, showcase the tools that we have developed in our project, and what improve the current state of the transport logistics operation, and then discussing how we are going to enable Industry 4.0 and seamless integration with the transport logistics sector, as well as gain an understanding of how this approach will be implemented and validated through the Freight platform, and how we are putting our milestone, our cornerstone, towards Industry 4.0 and the next generation of transport and logistics. What we are not going to do in the webinar, and we don't expect from people that participate either online or in person, is to make specific implementation commitments. So please simply an educational view of the webinar. We are not going to give a detailed technical training on how to develop software or hardware integration with the platform, merely our implementation and how we proceed forward. We will not product demonstration. The platform is ready, is available, but as I mentioned, it will be very brief today. We'll go through, and then we can go way more in depth with the tutorials, and of course, by when the platform is for the public, we can create accounts. And of course, we're not here to select, also to explore synergies and gather insights, and which will also come in the form of a post-webinar form sent to the participants to gather their opinions and have a way forward, and it's the perspective of all different stakeholders that are in this call and in presence. Okay, first, a small introduction to For Freight. So we're talking about For Freight. What is For Freight? So it's a European funded project which has the overarching goal through the different objectives to optimize multimodal use of freight transport capacity. How do we achieve that? We are implementing digital solutions in the form of solvers, the platform, and trials coming from the different sites, integrated with existing operational system in the transport logistics industry. And how do we do that? We take into account the legacy systems, and we're trying to present a solution that tackles multimodality, right? Why do we do that? We want to be able to increase the operational capacity, to increase the efficiency and enhance the efficiency of operations, and tackle on the side sustainability, while being able to actively target cost reduction and the footprint that the environmental footprint that is left behind from standard transport logistics operation. This is also a transition to, as we mentioned before, Industry 4.0. Now, this overarching goal split into 5 different objectives, right? Which we have tackled successfully. This is the last month of the project. It has been a successful project, and that is why we're also presenting the different scenarios coming from the various pilots. You will find the rest of the webinars coming like on our YouTube channel, so please give it a look. Now, the objectives are to create interoperable logistics solutions and integrate them with each other. So creating this multimodality, tackling from port to air and or last mile and so on. So you will see more how our scenario here evolves. In Paris, Romania, and Spain, and we are here to present one of the pilots, pilots in Spain that has been successfully executed. Being able to create, to provide to all the stakeholders the ability to manage logistics using real-life scenarios. So our platform is there to serve the industry and to make sure that we can apply these kind of scenarios and incorporate novel solutions. Then also, of course, taking into account the business model with it. So we're not from being able to produce new business models that are required for the industry to move forward. And of course, without forgetting the real life situation, to try and be compatible solutions with existing logistics standard. So for example, one of the partners of the project, TIC 4.0, has done a good job in producing and exploring standards and uniforming solutions and our solvers. Of course, you will see a few more details later coming from our pilot. Now, what do we provide? What is our value proposition coming from the project, and what I'm trying to achieve here is to create solving processes. So the big novelty of the project, as you will see later, is not only creating individual models, create this kind of unified solution coming through being realized through the Porphyric platform, and also being able to get data this map within the platform itself and create new solving process. So we are opening our platform to developers to be able for them to be able to develop new solutions coming from the library of the solvers that we have in the platform, as you will see later. And in that way, we're trying to tackle the usual transport and logistics problems that intermodality presents by using these generalized solving processes. We're trying to provide fast monitoring and trying to assess any impact that the solving process of the multimodality operations in transport logistics often create. So as I mentioned before, the environmental impact and the footprint that these processes leave. And of course, being able to create data to provide so the solution creators are not just academic models that are there to just academic problems and advanced research, but also in connection with real life application. transport hubs through providing standardized solutions. Okay, now the platform. So it is a system that combines information coming from legacy systems and different data sources. Coming from the industry standard problems. And of course, we are going to create this solving process, as I mentioned before. It's just a combination coming from different systems and then integrating them in the workflow engine. More about workflow engine later, a few words, and then you will see the workflow engine in practice, which is basically the way that we create these relations between various solvers, creating enabling the current solving processes that exist on the platform, but with also taking into account that we can create new solving processes based on problems that each are tailored to an individual or a company. Now, a few words about the Spanish use case. So in the Spanish use case, there are two scenarios. I mentioned which is basically scenarios come from problems that are really applied to our Spanish use case. Now, scenario one has also a similar webinar tackling that. So if I will urge you to go through that scenario because it is presented and we can we have material basically adapted to that scenario one, and you will get information in a more holistic picture. But essentially, what the scenario one does is Valencia port, which is also the head here. The people from Valencia port, because without them, literally, we would have had no use case to speak. And things to be able to move containers basically managed by our partners from Costco to improve port operations and transport to DHL facilities, while scenario two actually picks up from the DHL warehouse to the final manager, to the final customer, using as a distribution hub, the Metro de Madrid. Again, a big thank you to the partners that have enabled this scenario, and without their hard work, again, we would have nothing to present here. And the goal of scenario two, which I will focus on, is to use the most efficient, sustainable, and safest transport mode, taking into account the speed of delivery, of course, in the last mile distribution, and focus on the existing metro network, which is, again, a strength of the project and of the pilot itself, that we have such a big partner, such big partners to support this kind of scenario, which tackles real use cases that impact the pockets of individuals and enable the flow of cargo, the flow of products. Okay, and more or less these are the two scenarios, and the diagram here explains a little bit how this connection becomes, so how the two scenarios basically are connected with each other, and the need to break into two scenarios comes from the scale, the magnitude. So we are very proud of the work that has been executed in this pilot. What we have done as a general for the Spanish use case is to understand the root causes and the problem generation, and how do we impact, how have we identified, and how are we solving all of these issues, right? So first of all, we have a very known fact about the people coming from industry, from the transport logistics sector, is that even at this age, we have a very low digitalization of the existing processes, data, and so on. And the automation does not exist at the level that it should be, or the way that we would like to see, right? Of course, there is the lack of integration between legacy systems, and suboptimal resource planning based on information that is outdated by the time it arrives to the interested party. This is something also that you will see later how we deal with in scenario 2. And of course, the suboptimal multimodal transport planning and how this impacts really in reality the problems is, of course, increased greenhouse gas emissions, the increased container stay at the port, increased costs, congestion of traffic congestion coming from this kind of suboptimal multimodal planning, the suboptimal resource allocation, whether it is man hours, as you will see, there is a specific solving process in scenario 2 that tackles that issue, very limited visibility of cargo flow, and suboptimal transport logistics line performance. Our solving approach to this problem is to create what we've called before solvers, more about the solvers that specifically connect to the use case very soon. So what we're doing here is to create various categories of solvers, as we call them. For example, estimated time of arrival predictors, resource allocation planning predictor, and localizers, which are part of more part of scenario 1, and implement different technologies. For example, AI. You will see later, of course, individual presentations coming from our speakers. Digital twins, blockchain for privacy and security, 4G, 5G, and Wi-Fi, which is also something that interests specifically also IMEC and ID Lab on how do we, and it's going to be part of our plan moving forward after the project. So we do see a big future ahead of us. And of course, Internet of Things technologies to monitor, for example, in real time, various KPIs and freight itself, and which is also part of the localization with sensors, GPS, GNSS trackers, and so on. Okay, I'll go very quickly. Of course, as I mentioned, you will have the slides, so you will be able to see what I mean. But in the total in the use case, we have developed a lot of solvers that solve individual problems initially, and then a part of solving process. More about that soon. This is just a list of different solvers and what each solver does, and it's already available in the platform. And yes, as you can see, there's an extended list. I will not dwell too much on it because later we're going to focus specifically on the solvers that are connected to scenario 2. Okay, so as I mentioned, scenario 2 basically deals with data collection, for example, for package scanning. There's a very nice video on our YouTube channel that shows this processing live that was taken when we were demonstrated live when we were in Spain. And then this is just an example of a solver that we have, solver 15. It's about real-time location of the cages and being able to track them throughout the metro using mobile phone devices, and being able to know exactly when each parcel is at the final metro station, and thus decreasing loss of packages or any delays in the supply chain. Okay, and finally, before moving to this to scenario 2 specifically, what have we achieved in the Spanish use case is the improvement of information flow through, as I mentioned before, the real-time data exchange and increased digitization. We have improved the track planning and track staying at the port and terminal. This comes again from both scenarios, and the reduction of traffic congestion at the port area, scenario 1, and the city last mile, scenario 2. We thus successfully improving environmental impact, especially in terms of greenhouse gases emissions. Then we've also managed through the solvers and through validation with the trials to accelerate distributions through the nodes. For example, as I mentioned before, using the existing Metro de Madrid infrastructure, and at the end of the day, being able to create safer, faster, more sustainable, and increase the efficiency of the transport node in the last mile distribution coming from scenario 2. And now I will move a little bit about scenario 2. Okay. Okay, scenario 2 basically deals with optimizing the transport modes in the last mile distribution, focusing on the existing metro network, Metro de Madrid network. So essentially what we do is we start from the digital warehouse facilities where the parcels are being held, so scanned, then we move to configuring and identifying the exact order cages in different sizes. So our solvers take into account the size of the rollers as well to make sure that we are utilizing the full capacity without any losses, thus increasing productivity, increasing accelerating the process itself, and being able to handle more cargo using less metro wagons. So we start from the digital warehouse facilities, and the transport to the Metro Depot platform, and then while Metro Madrid, we tackle with services that tackle and solve issues with routing, and then transporting to the lockers in the metro station, identifying said rollers, unloading, and then distribution of the last mile delivery of the parcels in the different station lockers. So basically the transport through the network of Metro de Madrid. So we're tackling this part of the Spanish pilot. And how we do that? We specifically use 6 solvers. We use solver 4, which deals with multimodal route cost prediction. Then in conjunction with solver 5, then we have the multimodal route prediction of the greenhouse, carbon dioxide equivalent, which these together create a solving process, which is basically optimizing the end-to-end multimodal planning system. So again, this is a solving process that exists in the platform. Then we have solvers 8 and 9 that have been developed by our people here in NIMEC, by Hansi, which we are also very grateful for, and deals with prediction both in the freight demand and the workforce man hours to be operated. So we're using this together a part of solving process 4 for the Spanish pilot, which has to do with last mile resource planning and allocation. And then we have solver 12, which is by itself a very elaborate solver that creates its own solving process, which has to do with the route optimization, taking into account time, cost, and of course emissions. And this is part of its own planning system. And then we have solver 17, which is uses blockchain to enable stakeholder exchange of data for intermodal operations, and that is also something that we've put a lot of focus on, as we know that exchange of data between partners of the same pilot, but extending beyond the pilot, security is something that really is and the more go to the future, the more it becomes more prevalent to take care of such security exchange. And now some examples for scenario 2 is that we're tackling, of course, real world problems. We have also, please visit our website, for free website, because there we have deliverables that they go beyond what I'm describing now. But an example of a real world problem that we're solving through scenario 2 is that, for example, we have fragmented cost, emissions, and time data that this block be able to make decisions in an effective amount of time. And how do we solve that? We use, as I mentioned before, the optimal the solving process, which is called optimal end-to-end multimodal planning system. And in that case, we predict the cost associated with this transport, and then also the carbon footprint along how the action of the multimodal chain affects the environment. So that will also be used to avoid unnecessary fines from having such an optimized process. The solvers involved are solvers 4 and 5. And of course, another problem is that we have accurate forecasts that in turn lead to suboptimal resource allocation, so over or understaffing, especially in the port and the last mile delivery. And this causes inefficiencies, higher costs, and then again, if you have an unoptimized process, the environmental impact is far greater than having it streamlined. What is that we develop this the man hours. We have a model now, and this model can become even further elaborated and adapted to each stakeholder. So we urge you to use our platform and work with the solvers and see how you can also optimize your products. And just a small process flow diagram here. Again, I don't want to stand on it, but are being connected to different parts of this process flow. So we start by a customer placing an online order. Then the logistics operator receives the delivery order. Then we use one solver in the step of demanding of predicting the demand per metro station locker. That means that we are able to associate in real time the high peak and low peak hours, and being able to predict accurately what is the kind of how many people and how many resources in general do I need to for then that puts on the booking slots and making sure that the requests are being done securely and on time without any delays. And of course, taking into account that no gaps should be present. Then the delivery order is prepared. Then we have an evaluation of the different route plannings through our various solvers that I've shown before. And then we assign routes and vehicles to this optimal route that has been planned. Then transport the order cages to the metro depot, receive the receiver there, then being able to arrive, and we have a specific solver that keeps track of when those packages will arrive, and then ending at the customer coming to pick up the order securely with as low as possible environmental impact and in the most efficient way possible. And finally, before we move on to the next segment, which is the for freight platform demonstration, I wanted to just show a little bit of how some examples coming from the trials that have been executed already. As you can see, we have already been able to run different scenarios, different routes, different segments in real time. So this is also something I want to highlight about the project, is that to and to prove in real life how this works. So we've managed to see how different routes have different associated emissions and the cost as well as the time. So we are able to correlate and choose the best one depending on what we want to achieve. Optimally, all parameters are being optimized, but at least the user is able to choose which multimodal process brings the desired outcome, and this is something that you will be able to do through the platform. Okay, and with that said, let's discuss a little bit about enabling the solutions and the for freight platform. So, as I mentioned before, so what is the added value? First, let's discuss a little bit what is the added value of a freight platform to the transport ecosystem. First of all, we have, as we mentioned, integrated multimodal solutions. So we are able to, from different use cases and from different trial sites, again, in Greece, Romania, and Spain, we are able to see how we combine sea, rail, road, and air transportation into a seamless network, being able to, as we mentioned before, optimizing the routes or the emissions and making sure that we have as efficient process as possible. This is being this is also being verified and validated by real world tests. So we have this amazing consortium of big names and coming from different areas of the network, either in the academic sense or the industrial sense, and we all come together to produce this kind of trials and being able to provide to the people different algorithms and machine learning models for real-time visibility and being able to process in real life metrics that come data that comes from real process. Again, this is what we are accomplishing, which is a big feat. We have a focus on sustainability. So the platform, through the processes that it provides and the individual solvers, we can use them either or, either in tandem with each other or individually. We are focusing on sustainability and to meet various goals set by the sustainable goals from the United Nations, Sustainable Development Goals from the United Nations. The platform itself is enhances and has a focus into interoperability and flexibility by being able to integrate easily with legacy system and various logistics nodes, being able to use and being compatible with existing infrastructure, because we are focusing on the real world. That means we know that legacy systems cannot be become obsolete, will not become obsolete. We are not suggesting getting rid of legacy systems, but rather enhancing the existing infrastructure with our platform, thus also giving the business value to the customer. So we are building this platform and we are building this, and we are ending this project taking into account that we need to have a good business proposition. We want our platform to be spread and for you to try it. And of course, what is our competitive advantage? The competitive advantage of our freight is that we provide this. I mean, those of you that are that have more experience, you've seen platforms and platforms and platforms. What is the difference? Why is for freight different? Why is the for freight platform different? Because the for freight platform combines this multimodality with different solvers working in tandem with each other, the data flowing and the exchange of information in a secure manner, and increasing the resiliency of infrastructure. And a few words. So this is more or less the high-level architecture of the platform. We have the workflow engine governing this message exchange and being able to that enables the deployment of different solvers and creating solving processes. Then we have it's based on CI/CD, so it is easy to make changes within the pipeline and implement them directly into the platform, so no delays and no downtimes and people who use the platform. Then we have also different dashboards. We're trying to make the platform as user friendly as possible. So we are not targeting, and this is the most important part, we're not targeting just technically savvy people that have a programming background, that have a machine learning background. No, we are creating a platform that any stakeholder can use as efficiently as possible. There is the part, of course, that developers can develop new solvers and new solving processes with the existing solvers on the platform. And this is also something we are proud that we have successfully created. But we are also focusing on just being able to simply use our solvers and solving processes, right? And of course, the 3 use cases have provided all of the solvers that the platform has now available in its repertoire. Okay. As I mentioned before, just very quickly, I have logged in with one of our developer accounts, so I can show you more efficiently a little bit the platform. So the user is welcomed by the page, the home page of the platform, which describes the concept of the project and the methodology we have followed for designing the platform. And of course, we go through, so any time that you've used the solver or you have called a solver, it's shown in real time here, as well as you can choose the data that you have requested and to generate different charts. Depending on the solver you're going to use, of course, it depends. It will give you the outcome of the solver so that you can go back easily in history and being able to generate back the data you have produced in case you want to post-process it or otherwise compare different data coming from different solvers and so on. We have, of course, a comprehensive marketplace. So in the marketplace, you will find all of the solvers that have been developed, being able to execute them individually, as I mentioned before. So this is before going to the solving processes. So you have the ability to run an individual solver. And with that, I think, can you still see my screen? I think not, right? Is there an issue? Or can you see my screen?
Yes, we can.
You can. Okay, thank you very much. Perfect. Because on my side, it's a bit blank. Okay. Then, yeah, there is a description of the solver, what it does, and the category that it belongs to. So again, we will give you access to, to the people who are present here. They will have the opportunity to play a little bit with the platform. And for the rest, when the platform is, we urge you to visit our platform and sign in for yourselves and check it out. And of course, as I mentioned, we have also the solving processes, which are operating. So if you go to read more, you will see that, you can see what kind of interfaces you're going to, that they are being dealt with, the solvers associated with them, which legacy systems, if any, they are linked to it, and what is the real world problem that has been solved. So again, a big thank you to all of the partners that have contributed to it and who have executed the job. Then we have the intermodal interface wizard, which basically you can choose from which mode to which mode you want to see and what problem you want to tackle, and then you can submit your own data based on the problem you want to solve, and then execute this interface and execute and actually see how we ingest data, solve a problem, and so on. And of course, there is the workflow engine. Wait, I have to log in. Okay. And this is the part where the developers can use. So as I mentioned before, the workflow engine is basically what enables the solving process to exist on the platform. So what happens is that you can use. So here we have some pre-made examples coming from other flows, where you can literally drag and drop different solvers, connect them with each other, and see how the process is going to be executed, save it, register it, and then being able to run your own solving process. Of course, taking into account that you need to have compatible solvers with each other. When you will be able to onboard a solver, you need to make sure that it's properly executed and that the flow of information is seamless and compatible with each other. But yeah, this is just a small example. Again, as I mentioned, we have tutorials, more in-depth tutorials. This is just a quick introduction to the platform. And finally, this is the onboarding page for either solvers or solving processes. Just to not take too much of your valuable time, just mentioning the features of the platform. And we urge you, we are here to help you get started and to help you onboard or test your solutions and tackle your problems. So please contact us there is an email on the webpage of Freight, and of course you have our emails, so we will be able to direct you to the proper person, or we will be able to help you with the platform. Okay. I guess now you can also see my screen, right?
Yes.
Okay, perfect. Thank you. Okay, and finally, for this segment of the webinar, a look towards the future. What are the next steps? So now we have a running platform. We have achieved the goals of the project. We are moving towards the end. And what do we look forward to? First of all, we have again the platform scaling and adoption by the stakeholders. So this is also part of this webinar and the goal of our dissemination efforts. Stakeholders coming from academia and industry, so coming from our papers and being able to demonstrate the solutions. But we, of course, want to move with scaling the operations, scaling the platform in the future. So being able to execute more pilots and go from a simple proof of concept, or not so simple, a complex proof of concept, to continuous operation. So to be able to actually use the platform for industry and make sure that it meets the demands of the continuously growing demands of the industry. Of course, the solvers are there, but as we know, artificial intelligence models and algorithms are moving very fast. They evolve continuously, so we do not want to stay behind the curve. So what we're going to go is that, for example, an example that I've put here is from prediction to adaptive intelligence. More of that on the presentations coming forward, but it is basically using the latest state-of-the-art models to tackle the latest and more prevalent problems with the analytics industry. Of course, coming from the networking background, from our web networking background, we want to also move towards, since we are moving towards 6G networks and 6G applications, next generation connectivity. This will enable of operations that previously would have been impossible, like that require ultra low latency, and the ability to use communications, next generation communications, as an enabler for more solvers, or to be able to adapt to the demands of autonomous mobility. For an example is autonomous mobility, right? And this is what we call edge intelligence. So edge devices. Edge devices could be from a phone, from being able to have a near real-time, immediate receiving and processing of data using simple devices, or to the more complicated autonomous trucks in a port environment, and being able to reliably control them without any loss of property, lives, or any damages. Then, of course, we have not only sustainability by reduction of carbon footprint, but also making sure that the platform itself and the network that surrounds the platform is also energy aware and is able to design new systems. Create is new, like to go to federated ecosystems and go from integration of the platform to autonomous operation going through the platform. So these are just some long-term or mid-term, I would say, goals moving forward. And for now, this concludes the first part of the presentation. Any questions? And again, I will some time while going questions to link here the social media of our project, and yeah, anyone either in presence, online. Okay, then I guess if there are no questions for now, of course, the people here in presence will have some chance afterwards in the our break after the webinar to discuss. Okay, Then, without further ado, then I will stop sharing my screen. Has it stopped sharing? Now. Okay, I will move quickly to the next speaker. Mr. Hansi Dennis will present a part of our efforts in developing the solvers, and in that case, how have we managed and what is the science behind these predictive solvers, and the role of these two solvers in for freight. So, Hansi, thank you very much for joining, and yeah.
Thanks, Andreas, for introducing the subject. Good day, everyone. My name is Hansi Dennis. I am a PhD student at ID Lab, and in the scope of full freight, I've worked on the solvers 8 and 9, which are predictive solvers that aim to help with AI-based decision support. So those solvers, what they do actually is they forecast capacity, so the number of parcels that are going to be passing through certain parts or certain levels of the metro network, and the workforce, which is the main hours that Andreas mentioned earlier. And so we wanted to build some predictive solvers for transport and logistics, which would help in the planning and allocation of resources in the case of the forfeit project. So why did we need these solvers? So first, in logistics, as in many other fields, the demand is not fixed. So the demand of today is not the same as tomorrow. And most of the time, you want to build your operations with some prior knowledge of what is going to happen tomorrow, because maybe we know that tomorrow is an holiday, so we will have a higher amount of parcels that will be ordered. And in that case, we need to allocate more resources to match that demand. Second, we know that capacity and staffing must be planned in advance because, first of all, there are some distances to be traveled to get to the point where the work would be done. So we want to have an idea of where each, let's say, each resource will be at a certain time in order to avoid delays. And finally, we want all of this, we want to be able to plan and to match the demand, because over or underutilization can be costly and inefficient. For overutilization, we'll have some resources that are idle and that are not actually being used, and underutilization will make that the work will be overwhelming for the resources at hand. So those solvers aim at transforming raw data to actionable decisions. So in fourth grade, what does a solver look like? It's not necessarily a dashboard. It can be a mathematical or AI-based model, such as in our case, and it produces quantitative predictions under constraints, meaning that we want to output a value, but we want to output a value that's going to be meaningful to the end user, and that's not going to make zero sense to them. Because obviously, the people that are going to use the solvers and to use the website are not forcefully people that are aware of machine learning and AI, and we want the results to be actionable. So in forfeit, we have two types of solvers, the predictive ones and the prescriptive ones. In our case, we worked with predictive solvers. Their aim is to forecast future system states, reduce uncertainty in planning, learn patterns from historical data, and provide probabilistic outlooks. This means that we don't want to give a straight answer, a straight value that might be false, but we'd rather give a range of values that can be observed in the future time. As an example, with the parcels, instead of saying that in this particular station, the next day we'll have 50 parcels, we can say that we'll have between 45 and 60 based on historical data. So in that case, the typical outputs are demand forecasts, capacity forecasts, and workload projections in terms of man hours. The other type of solvers that we have in Forthright are the prescriptive ones. They recommend actions or plans, optimize under constraints. They balance across multiple objectives and explore the trade-off between those said objectives. And in those cases, the outputs can be schedules, assignments, and optimized plans. So where does ES08 and ES09 fit in the Forthright platform? So their input is historical operational data, and the output is short-term capacity and resource forecasts. So the input will be data from the past days that has been recorded. Let's say that on the last week, we have taken into account every single station and the number of parcels that went there and the number of man hours that were employed in the different station. Based on this, we will pass them through the solvers that will perform the prediction. And those solvers then address scheduling, slotting, workforce planning, and metro integration decisions. So for ES08, which is a straightforward capacity prediction solver, so we only predict the parcel volume to pass in different places. It is also interesting to add that for both ES08 and ES09, we performed hierarchical prediction, meaning that we predict at different levels of granularity. We can predict at the level of the whole metro network, at the level of each depot, at the level of each line, and then for the most precise one, at the level of each station. So in that case, from the raw data that is 30 days of simulated or recorded data, we will take 7 days from a specific depot and then pass them through our model, which is based on the time series dense encoder, which is an AI model that can predict the next steps of a time series, so the next steps of a series of values based on that series of values. And then the output is the number of parcels in the next day. So below, we have a visualization of the prediction over 80 days, because obviously we can then use that prediction to predict again. Of course, we know that there is some error accumulation. So the further we go from the original 30-day simulated data, the less reliable the prediction is. But from experience and in the project, we experimented that the prediction model we used was accurate enough that the predictions even further in time were still quite accurate. So ES08 predicts the number of parcels and the number of rollers. So the rollers are basically the platforms on which the parcels are transported through the trucks and the metro network. And those are categorized as small or light or large. Here, in terms of hierarchical prediction, the prediction is done per line within a depot, and the forecast horizon is 7 days. So we use the 30 days of historical data, and that helps us learn recurring patterns on daily cycles, weekly trends, and the volume fluctuations, notably through the year. As an example, the period at the end of the year is very busy because of the holidays, and the summer is very, very calm because of the school vacations. So we output probabilistic capacity forecasts, meaning, as I said earlier, a range instead of a straight value. And the concrete impacts of this solver are better slot allocation, reduced congestion at depots, and improved coordination with downstream transport. So this model, all in all, captures operational rhythm and can learn from trends during the years and during the weeks. So for ES09, which is basically an evolution of ES08, we predict both capacity and the workforce, so the man hours that are going to be needed in the future time steps. So in the same way, we predict in a hierarchical way, but in that case, we predict per station. So we predict with a more precise level of granularity. The forecasting horizon is the same, and the input data is a little bit different because we also take into account the processing times, the line level performance, which means that to get the man hours, instead of just taking the number of parcels that came to the station in the last few days. We'll also take into account how much time does it take to put the parcels in the different lockers? How much time does it take to take the parcels from the metro to the bank, and stuff like this? We try to model every single operation that has to be done in the station in order to get an accurate prediction. So the key insights from this solver are that the infrastructure capacity is different from the operational capacity, and that workforce availability is a critical constraint, because in terms of man hours, if we have less man hours allocated than the ones that are needed, we will be overwhelmed and there will be a significant delay. So the examples here are staff shortages, peak hour bottlenecks, and inefficient shift planning. Of course, in our study on man hours, we didn't use any personal data and we didn't track any individuals. We treat them as a big batch, let's say, of workers, to keep privacy, their privacy respected. So how do ES08 and ES09 enable scenario 2? They provide volume certainty and workforce feasibility, which answers the questions of the requirements of advanced planning and enables a reliable integration with public transport. So from my presentation, the key takeaways I'd like you to take home are that those solvers transform data into foresight, that they reduce uncertainty, and that they enable sustainable decisions via predictive intelligence, because we can avoid over or underutilization of resources. Thank you very much for your attention, and I will be pleased to answer any questions.
Thank you very much. Thank you, Hansi. Thank you very much. Any questions that you may have from our audience here or online? Okay. Thank you very much. Thank you, Hans, again. Okay. And with that, we'll move on to the next speaker for today, Professor Sigrid Merselis from the University of Antwerp, to present his presentation on how AI in transport logistics enables the next generation of multimodal logistics. So please, the floor is yours, and thank you for joining.
Thank you, Andreas. All right, so yeah, transport and logistics are among the most complex operational systems that we manage today in our society. Logistical chains are highly dynamic systems, meaning that decisions are taken continuously under a lot of uncertainty and at a very large scale. Demand also fluctuates, traffic conditions change, disruptions are the norm rather than the exception. But at the same time, these decisions are tightly constrained by cost, service quality, and of course, an increasingly sustainability requirements. And this combination makes transport and logistics a natural domain for AI, not necessarily as a replacement for human expertise, but rather as a way to support complex decision-making at scale. Looking at why transport and logistics need AI, there are actually 4 structural reasons why AI is particularly relevant in the transport and logistics sector. So first of all, the systems are highly dynamic, meaning that planning doesn't happen once per day or per week. It's a continuous process with a lot of disruptions, and even a well-optimized plan can become outdated at very short notice as soon as the conditions change. Secondly, the logistical sector operates within very tight margins, and operational costs are high. Think about fuel, labor, asset utilization, and so on. So even small efficiency gains can actually have a very large economical impact. Thirdly, sustainability constraints add, of course, another layer to this complexity. Emissions, energy use, and modal shift targets must be considered alongside traditional performance metrics like cost and time. And finally, the sector is fragmented. There's many stakeholders operating their own assets and legacy IT systems, which of course limits the visibility beyond organizational boundaries. What makes this particularly challenging is that these factors do not act independently. Dynamics, cost, sustainability, and fragmentation reinforce each other. For example, sustainability constraints can reduce the flexibility certain routes that could be more efficient might, because of this aspect, become less attractive or available. And of course, this increases the operational pressure and cost sensitivity. At the same time, fragmentation means that no single actor has a full overview of the system, even though decisions propagate across the entire network. And so in practice, this leads to planning that is often conservative and reactive, where humans simplify the problem to keep it manageable, but the simplification typically leaves efficiency and sustainability gains on the table. And AI can help by handling this multidimensional complexity explicitly rather than implicitly. Now, AI is already widely used in operational logistics today, and mainly to optimize very specific processes. So we can do demand forecasting to anticipate volumes and peaks, do route optimization to adapt routes dynamically based on traffic and constraints. We can also do capacity planning to support decisions about vehicles, drivers, and warehouse space. We can do predictive maintenance to shift maintenance from reactive to proactive measures. Finally, also ETA prediction to improve the reliability in customer communication. Most of these applications focus on local optimization, that they improve individual processes or organizations, but they typically don't consider the broader system which these decisions take place. Hence, there is a need for this larger overarching solution like the one presented in for freight. Now, it's quite useful to see the integration of AI in a company as an evolution. It all starts with digitization, which makes data available. Which then goes on towards automation, where we typically look more into fixed rules or processes. The next step, of course, is an optimization where we look for better solutions within a given set of constraints, like we discussed before. And then finally, intelligence will allow us to make an adaptive system that can also gradually improve over time. Now, of course, this transition is often not straightforward and faces several challenges due to the complexity and scale of logistical systems. And transport logistics, automation alone quickly reaches its limit because the environment is too dynamic. Optimization is often a trade-off between computational feasibility and how optimal the solutions we can actually obtain. And finally, of course, intelligence means that we need to support decisions that have to be revisited continuously as conditions change, meaning that the model should also be fast and generalized well across a lot of different scenarios. So these are definitely still significant challenges for the future as well. But more importantly, when considering AI for logistics, is also not a single technology. On the one hand, you have predictive AI, which is about forecasting demand, congestion, delays, and so on, possible also capacity. Then there's the prescriptive AI, which decides which actions we should take, such as routing and scheduling. And then thirdly, there is learning systems. These are then systems that improve performance over time by incorporating new data and feedback. So the key point is that predictions without these decisions have limited value, and decision-making without learning also doesn't adapt to change and is not future-proof. As already highlighted, a lot, of course, depends on the data that we have, and it's crucial to, of course, have this data available if you want to go for these very advanced AI-driven decision-making systems. AI systems must, of course, combine operational data like vehicle and timetables with infrastructure data from ports, warehouses, metro systems, and with context data like weather disruptions and regulations. And in practice, we see that data integration is often still a bottleneck. The challenge is not only technical, but also organizational. So logistical data is not heterogeneous. It's also unevenly distributed in time and space. The operational data may be available in real time, while infrastructure or regulatory data changes more slowly. Context data often sits somewhere in between. And this means, of course, that decisions are made under partial and synchronous information. So AI systems are valuable because we can reason under uncertainty and update recommendations as new data arrives. So it's quite important to capture all these details and differences between the data availability, but most of all, make sure that we can connect all these different data sources together. And AI, of course, then only works if data integration is approached as a system level, where rather than each actor integrating the data for local optimization, we look into global coordination, data sharing instead. My most logistical application, AI acts as a decision support system rather than autonomous controller. So where we see that AI actually proposes infeasible and optimized actions while humans remain in control and make the final decision. And this is, of course, particularly important when we deal with trade-offs between cost, time, and emissions. And AI can help make these trade-offs explicit and quantifiable in supporting informed and transparent decisions. But of course, we do see the role of the human in the loop in these kinds of systems, and considering AI here as a tool to enable better decision making, not necessarily having a fully autonomous system that would replace the human operator, but rather an additional tool that can help experts in taking more informed decisions instead. Now, looking then at AI for sustainability and an enabler for green logistics, as I mentioned, AI is capable of actually balancing different KPIs when targeting optimization. As you can see in the figure on the right at the top, transportation is actually a sector responsible for a significant portion of our energy consumption. And where AI can contribute here is to take this energy consumption and CO2 emission into account when targeting global optimization of these logistical chains. So for example, by load consolidation, by pushing towards a modal shift and trying emission-aware routing, energy-efficient operations, and so on, trying to gain a maximal positive impact on energy, while trying to, of course, make it also a sustainable operation from an economical perspective at the same time. Now, considering then the system level intelligence that we talked about, so traditional optimization in logistics is isolated within one organization. So an organization optimizes their own operations, focuses on local KPIs with limited visibility beyond its own assets, often also because of limited access to external data sources, meaning that sustainability as a result is often treated more as a constraint rather than an objective as well, since the focus on the local KPIs is often cost and time. Now, in system level intelligence, we can, of course, change this, where we can then optimize decisions across different actors and transport modes using multi-objective criteria such as cost, time, and CO2, and balancing them all, trying to make transportation more sustainable in general. And for freight example, instead of a company optimizing only truck routes, the system can also consider when and how parcels, for example, can enter the metro system, taking capacity, schedules, and emissions into account in this sense. And so system level intelligence introduces in this way a different kind of logic and a different way of looking at logistical process. And instead of asking what is optimal for one actor, it asks what is optimal for the system as a whole and distributed accordingly. Meaning, of course, that this requires explicit modeling of the interactions, capacity constraints, timing dependencies, and so on.
I'm afraid that, I took notice from Professor Meseli that he has a small technical issue. So I would invite, unfortunately, he has an issue with his PC. So I suggest to proceed with the next talk, and then we will resume. He's on to resolve it. So I will invite now Maria Ramirez Gutierrez from DHL to give the talk about the industry perspective for freight and the solutions developed in scenario 2. Maria, the floor is yours, and we will resume with the previous talk immediately after.
Okay, just give me a second because I was just losing the connection as well. Just give me a sec.
Yes, of course.
Okay, can you hear me?
Yes.
Okay, good. Yes, I was. Well, my contribution will be very, very brief, because all the technical deep details are being displayed and very carefully explained in what all you are exposing at the moment, the previous speakers. And what I just want to contribute here, even though this workshop has let's say a more academic perspective and more technical perspective, I would really like to highlight the importance of keeping the industry within the development. And that's been the case of the forefront, because from the very beginning, all this data exchange, all the architectural development, all the solvers, the structures, the different connections have been possible thanks to the fact that the industry has been considered from the very beginning, and not just the final customer receiving the finished product, where they are that is just solving A, B, and C. So being said this in the general terms, all the solvers used in the scenario 2 that concerns the connection between DHL and Metro de Madrid, some of them may seem, let's say, some simple in the best meaning of the word, but first of all, let's understand that this relationship did not exist before this project. So Metro was not part of what the logistic chain is doing at the moment. It's DHL delivering, or other subcontractors or other transport and logistics providers operating. So the first challenge we had there was just how to introduce within the chain someone external that whose main core business it's not logistics, and that's the case of Metro. And for us, the best approach we found was just cooperating and considering them not as a public entity or just a pilot partner, considering them as part of the business environment. And that was the critical point from where we started. They were part of the business, and they were considered as part of this transport business, because it's for all the private companies involved, it's not just about, of course, we're very much into reducing emissions and sustainability, but we need to do something feasible in terms of business. So the main
Maria?
concern, yeah?
Sorry, are you sharing slides by any chance?
I was, but
Because I think it stopped sharing. Can you try sharing again, please?
yeah, give me a sec. I don't know what I'm doing. Sorry about it.
No worries, no worries. It's just that I was just wondering, just in case, because I thought I saw something, but then I not anymore. Yeah. Okay. Okay. Sorry again. Maria just notified me that she has some issues with her laptop. So then, Professor Marcelis, if you can finish your presentation, and then we can move to Maria. Yeah, and I will the presentation together. Yeah, please. So yeah, yes.
Jump in where Microsoft decided that it wanted to enforce an update.
Yeah, this is happening live. Yeah. Perfect. Okay. Yeah.
Yeah, so where was I? So traditionally, optimization was mainly performed within one organization, focusing on local KPIs like cost and time, making it, yeah, the visibility onto the own assets quite limited, in making sustainability often more of a constraint rather than an objective. What we see now with these coordinated ecosystem-wide intelligence, like Infor-Freight, we can optimize decisions across different actors and modes, but also focus on multi-objective decision-making, where sustainability is inherently part of our decision-making process, essentially making also our awareness of the whole situation of the ecosystem a shared aspect that we can optimize over, where we can inherently also embed the decision-making, the sustainability into the decision-making logic. And for example, again, Infor-Freight, instead of DHL just optimizing only truck rides, the system can optimize when and how parcels enter the metro system, considering capacity, schedules, emissions, and so on. Now, despite potential, of course, AI in logistics does remain challenging, where we see the main challenges being mainly around data silos. So there's often legacy systems with potentially also very isolated data, with often data of low quality. So that's a key aspect to tackle first when going towards these holistic AI integrations. Where of course the platform also should support trust and explainability, as well as regulatory constraints and any kind of concern that companies might have with data sharing. Same goes, of course, for challenges with legacy systems, because often data is not, the data might be there, but it's not directly accessible in a format that is easy to process or share with other partners. And of course, as I said, just the trust and explainability are a key aspect to take into account when setting up these platforms. And of course, the regulatory constraints are essential to factor in as well. Hence, a platform like Infor-Freight matters to actually make all of this happen. So to conclude my presentation, again, transport and logistics supports this complex type of decision-making in dynamic multi-actor systems, where we can explicitly factor in important aspects like sustainability and overcome the ongoing challenges in optimizing large-scale logistical systems by moving from isolated optimization to system-level intelligence enabled by holistic data sharing. Let's say, where we can embed sustainability explicitly in our strategy. And thank you for your attention.
Thank you very much, Professor Marcelis. Thank you for the presentation and again for being here. Any questions, either online or in person? No? Okay. Yes. Okay, perfect. Then do we have, is Maria back? Maria, are you here? Okay, I suggest we take a small break for 10 minutes until we can get the connection back, and we will proceed with the last, with the remaining part of Maria's talk before we close the webinar. So I will stop the recording now to allow for some time. Yeah, please stay online. We'll be back very soon. So I propose a 10-minute or so break. Anyway, for us in person here, we will take it here in the same room as we are. So whenever we're back, we'll be here. Thank you very much. Very soon. We will be back very soon. the audience and this thing. No worries. Thank you very much. Great. So please, continue. Yeah.
Well, I would just try to go faster now that we've wasted so much time here. So what I was saying is that in the second scenario of the Spanish use case, as you all know, we were connecting metro as part of the logistics chain and transport, and that's absolutely new. And despite it may seem simple, it's not simple at all, because it's a relationship that doesn't exist, not only from the physical perspective of loading and unloading parcels or moving them from A to B, but also from the data exchange and predicting what is going to happen in terms of efficiency connected with the business operation. And that was where we started, and I think that was part of the success of the fourth period in our case. That from the very first moment, the technical developers and were working hand in hand with the business partners, which were, well, in our case, AHL and Metro, but also Costco from the scenario one. So that was a critical part of it. And since it was a successful cooperation, we were able to develop within the frame of the project useful tools that are really meaningful and impactful for our business, the daily operation. So you see here a schema of the process flow that happens within the scenario two. What happens with the connection between Metro and DHL, and as you see in the down part of the screen, two legacy systems were considered here. The what happens in the warehouse, the warehouse management system, and that prepares all the parcels within the warehouse to be sent to the specific metro line and metro depot and the specific route until they reach the specific station of destination, and the transport, which means what happens from the warehouse to the metro depot, and from so we can track things, we can activate the optimization of the routes. So in the end, what we got, it's extremely realistic solvers where we were able to predict the man hour, the most cost-effective routes, the most time-effective routes, the forecast demand, and according to different metro station lockers, the request locker, the booking slots, we were able to keep track of what happens to each of the parcels in each of the roller cages on each of the critical steps of the process. So it was an exercise of optimizing the technical development of the solvers, but adapted to extremely realistic and feasible processes. So that was the core of the success. And you see here all the solvers developed by mostly IMEC and Fundación Valencia Port, and how they just impacted this what we were doing. So we carried out several measurements of the different solvers, considering the baseline we have established at the very beginning. We carried out several trials, considering both the physical trial per se of just moving physically parcels from the warehouse to the metro depot, to the metro train, and to the final station. But we were also able to scale it up, and scale it up to a much larger scale that consider not only one metro line with one metro station for a certain day or a certain period of time. We were able to scale it up to several metro lines, moving thousands of parcels over months. And that was thanks to the development of the digital twin tool, and which gave us not only the perspective for what could happen in Madrid, but also the perspective to what may be able to be expanded and be applied in several other areas. So what started as a tool for the project, for the specific project development, has transformed into the most powerful part of the offer in terms of future business exploitability, because this tool will allow anyone with an intention to check what could happen in their metro network within their logistics suppliers, just to replicate what we've done in Madrid in their metro networks. It's just an example, if Paris Metro tomorrow intends to look at what we have done here in this project, it will not only be about checking what it's done, but also testing themselves what they can do. So that testing with their own data, with their own historical data, with their own metrics, could be carried out thanks to the development of the tools we have done in the Forthright project. So that's one critical asset from the perspective of business exploitability. And I just want to check extremely fast, the results achieved during all this testing within the project. So basically, we achieved all the KPIs established in the project. That's extremely important for us. But not only achieve them, but also overcome them with quite high percentages. And this is not because we set very low baselines. It's because we were really well connected from the very beginning, and this is how we have achieved just increasing the number of parcels delivered with a much reduced number of vehicles, and decrease considerably the greenhouse emissions and the operational costs and so on and so forth. And the more we continue using what we have developed within the Forthright project, both in the physical context and in the simulation context, the more data that could be ingested, and the more the model will be adjusted and implemented, and the more accurate it will be for the next partners coming into the platform. So as that's more of the results achieved, and that was basically my contribution for just showing here that all the technical developments that have been explained before have a very specific and very realistic application, and that application has been tested both physically and in a reduced scale, let's say, and in a much wider scale by simulation, and that those simulation tools will be the next step for anyone interested in testing what could happen and replicating what we've done here. And that's all. Thank you very much.
Thank you very much, Maria, for your presentation. Thank you for the really great insight from the industry perspective. Any questions online or in person? Okay. Well, of course, as I mentioned, you can contact us at any time if you have any questions, if you have any and also please we'll send also some post webinar survey, a very short one, just to record the people participating and just their opinions and so on. We will also use those results for the review meeting, the final review meeting, to present some insights for the people participating. For the rest of the people that are here, of course, we will show you a little bit the platform. We'll let you sort of test around with the account that we have, the test account that we have. But before we close, I want to send a really huge thank you to the coordinator of the project, Serf, for coordinating this huge effort. It has been no small feat. Some people from CERT are in the call. So just a huge thank you from my side, IMEX side, for everything they have done for us. So yeah, really great thank you, big thank you. And then without stalling any further, I will stop the recording here of the webinar. Okay,